Our factoring review will start with factoring GCF, which stands for greatest common factor. We're looking at each one of the terms. Terms are things separated by addition and subtraction, and determining what's the highest value that we can pull out in terms of the coefficients in front of each one of the terms, and then how many of each one of the variables we can also take out that's common. So let's begin with the numbers. If I take a look at 40, 25, and 15, what's the highest number I can think of that goes into all three numbers? That number is 5. So let's begin with, I'm going to take 5 out for sure. So from there, we look at our x's, and each one of those terms has 2 x's in it, x squared on the first one, x squared on the next one, and then x cubed on the last one. So at most, I can take out 2 x squareds because each one of those has 2 x's at least in it. And then looking at the y's next, I see that the first one has 2, the second term has 3, but the third one only has 1. So at most, I can only remove 1 from each one of the terms. So that's my GCF, 5x squared y. Now you can do the next part in one of two ways. You can either think of the fact that you're doing reverse distributive here. So 5x squared times 5x squared y times what is equal to 40x squared y squared. So in trying to determine that term, you can put 5x squared over y underneath each one of your terms and then divide out to see what's remaining. So the reverse of distributive or multiplication is division. So 40 divided by 5 is 8. And I'll show you guys as I'm doing it. 40 divided by 5 is 8. X squared divided by x squared is 1. And then y goes into y squared y times. So there's a y left over. And then we continue on. The next term would be negative 25 divided by 5, which is negative 5. The x squareds cancel out. The y goes into y cubed, y squared times. And the last term, 5 goes into 15 3 times. There's an x left over when I divide x squared by x cubed. We subtract exponents as we do division. And then here's the question. If I have a y on top and a y on the bottom, y divided by y is 1. And so if I do this correctly, you can always check your work by taking each one of the GCF and then multiplying by each one of the terms inside. And the question is, do I get back to the original? Which you do. Now, on the second one, we're going to see that we only have 2 terms here. That's my first term, that's my second term. So what is the biggest number that goes into 18 and 15? That number is 3. So we're going to take a 3 out for sure. That's my GCF. Then there's an a in both of the terms, so a. And then the first term has 3 b's. The second one has 2 b's. So we at most can take out 2 b's. And then from there, we're doing reverse distributive. 3 times what is 18? 3 times 6 is 18. A times what is a? A times 1 is a, so we don't have to put anything here for that. B squared times what is b cubed? B squared times b. Minus 3 goes into 15 5 times. Again, there's an a outside, times 1 would give you the a inside. And then b squared times 1 would also be b squared. So my final answer is 3ab squared is the GCF. And then parentheses 6b minus 5. One thing I would suggest that you do also, again, reverse distributive is what we're doing when we're factoring GCF. So distribute out and double check, do I get back to the same answer that I did at the beginning? And if I do, I know my answer is correct. Also, if you want to take a look inside at the terms that you have left, you want to make sure there's nothing else you could have possibly taken out. Sometimes we realize that we could have taken out a bigger number or more letters. So if you see that you have multiple letters in those 2 terms,